Welcome to the first lesson of calculations. Today we're going to look at how to calculate relative atomic mass and how to calculate relative formula mass. The first thing we need to do is look at relative atomic mass. In order to do that, we're going to do a slight recap. So I'm going to just recap something with you. First of all, an atom recap. So remember that in the center of the atom, we have a nucleus. In the nucleus, we have positive protons. Go full screen. Okay, so the first slide is about Dalton. So Dalton came up with this theory that everything is made of solid spheres called atoms. But the current model looks like this. We will discuss history of the atom in a separate lesson for those of you that do AQA. But electrons orbit the nucleus in shells or energy levels, and they have a negligible mass with a negative charge. And the protons and neutrons are found in the nucleus, where we have positive protons and neutral neutrons. They have a relative mass of 1 to 1. Now, this is a summary of the table. The electron mass there is 4 significant figures, but you can just learn it as 1 over 2,000. We learned that mass number is the protons and neutrons, and the atomic number is the number of protons. Then we learned about isotopes. The reason I bring up isotopes is because they'll be required for relative atomic mass. So an isotopes are atoms of the same element with a different number of neutrons, but obviously the same protons. So here you have 3 isotopes of oxygen. So notice how they all have a different mass number because the neutrons are different, but the atomic number is always 8. Otherwise, you will change the element. Now, when you average the mass of all these isotopes, that's when you get the relative atomic mass. So the official definition of relative atomic mass is the weighted average mass of an element compared to the mass of 1/12 of carbon-12. Now, why did they pick 1/12 of carbon-12? That is actually because 1/12 of 12 is 1, so everything is compared to 1. And carbon is very abundant and is a solid. Now, you might say, why not compare it to hydrogen? Because that's also 1. Well, hydrogen is a gas and it's much harder to obtain, to compare it to. But secondly, hydrogen is actually, if you look at the very detailed periodic table with many significant figures and precision, it's 1 point something, something, something. And it so happens to be that when you do 1/12 of carbon's 12's precise value, you actually get a number closer to 1 than hydrogen. Okay, you can look this up if you look at the actual mass of hydrogen or carbon. Let me show you. 1 second. Okay, so if you go mass of carbon, 12.011. Okay, so if you take 1/12 of that on your calculators, 1 divided by 12 equals times 12.011. We'll get 1.30 and then 9. Now, if we look at hydrogen, mass of hydrogen, notice how it's 1.007. This was 1.00. So an extra 0 means this is a small number. So it is actually closer to 1 and is more abundant. So that's why they used carbon-12 as the comparison. But anyway, that's not really relevant for the exam. What's relevant is that you can calculate the relative atomic mass. So let us look at how you calculate it and practice a few examples. This is called a weighted average mass because it depends on the abundance. So imagine you have 90 balls with a mass of 200 and 10 balls with a mass of 300. So total in the bag is 100. But then you have to add up all their masses. So it's 90 times 200 plus 10 times 300. And then when you divide it out, the average mass of all the balls will be 210. You use the same principle with in chemistry here. So look at this example. It is the mass number of the isotope multiplied by the abundance, and then 37 times 24.2, and it's all over 100 because it is a percent abundance. If they don't use percentage abundance, if they use relative abundance, then just put the total on the denominator. It just has to be the total of the abundances. If it's a percent, it'll always be 100. So I will only do one example because it's a very relatively straightforward process. So for lithium, I would do 6 times 7.6 plus 7 times 92.4 all over the total of these two, which is going to be 100. Don't times it by 100 at the end. That wouldn't be very smart. Okay, and that will give you a number of, I think, 6.93. Obviously, you can check that on the calculator. I can have a look on the mark scheme. And I was one off, it's 6.92. Okay, good. So that's how you do it. Have a practice at the worksheet. They're easy questions to get right in the exam. You just need to know the definition and how to calculate it. Sometimes they might make one of these the unknown, so you would have to call it X and then form an equation. But that would be a higher tier question. Okay, next we're going to move on to MR, relative formula mass. Now you may see the word relative formula mass and relative molecular mass, RMM. Theoretically, relative formula masses for ionic compounds and relative molecular mass, RMM, would be for covalent molecules. However, in the end of the day, you can just call it MR, and it just means the total of all the atomic masses added up together for all the atoms. So an example would be this one. Now you do need a periodic table for this. I'm just going to put one on the side just to show you where I'm getting the values from. So mg, always the bigger number. So if the new periodic table is the bottom number, then it's the bottom number. Always look at the key. We need the relative atomic mass, not the proton number. So here we have mg NO3 twice. We have 1 mg, so 24, which is from here. Nitrogen is 14. So we have 14 times 2. And then we have 3 times 2 is 6. We have 6 times 16. That's one way of doing it. I prefer actually to add up what's inside the bracket, then double it. So I would go 24 plus bracket, then 14 plus 3 times 16. So 14 plus 48, 3 times 16. And then I will times the whole thing by 2. That's my preferred method, because it avoids the error of multiplying out the atoms incorrectly. Another example would be here. This dot I've mentioned before means water of crystallization, which means it has 5 water molecules bonded inside that crystal, within the crystal. In chemistry, this means plus. It does not mean times. So Cu is 1. So 63.5 comes from here, Cu, plus 32, which is sulfur here, plus oxygen, which is 16 times 4. Where is it? 16 times 4. There it is. Okay, then I don't like the way they've done this. They've done 5 times 2 is 10 and 5 times 16. I prefer to just add the waters at the end. So if I were doing this question, I would do 63.5 plus 32 plus 16 times 4, which is 64, plus 5 times, then I will just add up water. Water is 16 plus 2 times 1, which makes 18. So essentially 5 times 18 needs to be added at the end. Either way, you'll get the answer correct. You just need a bit of practice on this so that you don't make easy mistakes. You will be surprised that even A-level students will mess up their MR. They'll do one thing wrong. So always triple check these. The best way is to just practice on the worksheet I've attached. So this worksheet here, I'm going to do one example. I'm going to take this one. So aluminium NO3 3 times. So aluminium is here, 27. Plus, then nitrogen is 14, plus oxygen is at 3. 3 times 16 is 48. So 48 brackets. Then the whole thing has to be tripled. So that would equal 27 plus, and then 14 plus 48 is going to be 62 times 3. And then you just put that into your calculator. I don't have the calculator on me right now, so that's going to be 6, 18 plus 27. It's going to be 7 plus 6, 13. 213. Okay, and that's the answer. Now you might ask, what are the actual units for this? Theoretically, the units are actually G mole minus 1, which is grams per mole. You don't know what that means yet, but you will when we do moles. You're not required to put units for MR though. So the whole periodic table is G mole minus 1. So all these numbers are 27 is G mole minus 1. Okay, but you will learn what that means later, and you actually don't have to put units for this. Okay, so practice this, and then there's one more part to understand, and that's called calculating the percentage composition, or the percentage by mass. That's the last part of this. The next lesson we'll do moles. So this is actually very simple. You're looking at, for example, if you have a class of 100 children and 70 are boys, what percent are boys? Well, it's going to be 70 over 100 times 100, which is 70%. So it is, in that sense, very relatively straightforward. If you are someone who likes equations, I do have it written here as an equation. 1 second, there it is. Calculating percentage by mass. So if you like equations, it will be the number of atoms of the element that you're looking to find the percent of, multiplied by its AR, over the total MR of the compound times 100. That's technically the formula, although it's common sense. So if I go back to the worksheet as an example, it says find the percentage of oxygen in sodium carbonate. Well, the first thing to notice is there's 3 oxygens. So you put 3 times 16 on the numerator, and then you just add up the whole thing. So sodium is 23. So 23 times 2 plus carbon, which is 12, plus 16 times 3 still included because we're looking at total mass. So that gives you 106, and that's your denominator. So you should check that you can see where these numbers came from in the periodic table. So as I said, the total percent of oxygen would be 3 times 16 over the total times 100. In this case, it's going to give you 45.3%. So I will give you one example. I'll go through one example. Then you can try the rest on the worksheet. So let us do D. So find the percentage by mass of the element, so oxygen. I should bring up a periodic table as well, just to help you see where things are coming from. Where is it? There it is, periodic table. So if we're looking at this one, oxygen. So oxygen is 16, and there's how many oxygens? Well, it's 3 times 3 is 9. So it's 9 times 16 over the total. So for the total, you've got 27 for aluminium, plus, now remember, I like to do what's inside the bracket first, then times it by 3. So nitrogen is 14, as you can see here, plus there's only 3 oxygens in the bracket, which is 3 times 16, 48. Then it's times 3. So 14 plus 48 was 62. So it'll be 62 times 3 here. Then you multiply the whole thing by 100, and you will get an answer of, now since I don't have the calculator, we'll just find it here. Answers. The answer will give you 67.6%. So 67.6 would be your final value. The 3 significant figures. Always read how many significant figures. So these questions, they're not that common, but they can come up. So just don't forget how to do it. Okay, that brings an end this lesson. Practice these 2 worksheets though to get a good grounding. And the next lesson, as you can see, we're going to move on to moles. So see you next time.